Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is November 2017, paper 3, higher tier. Now, with the new specification being new, grade 9 to 1 past papers are like gold dust, and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback, and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Okay, so let's get started on the November 2017 paper 3. Question 1. Circle the inequalities shown by the diagram. Now you'll see that all the answers go from -4 to 5, so it's not the actual numbers themselves that we're particularly interested in here. It is whether or not, or which way around the inequality signs go. Now an open circle, when you draw one of these lines, means the endpoint is not included. So that means that x, our unknown value, must be strictly greater than -4. So it could be that one or it could be that one there. It's not this one and this one. And then looking at the other end, we've got a closed circle here, which means that 5 is included in the range. So it has to be that one there, then, that x is less than or equal to 5, which means our correct solution is this one here. -4 is less than x, which is less than or equal to 5. Question 2, y is 100% more than x. Circle the ratio x to y. Okay, so we always start off with 100%. So if x is 100, so x to y, if x is 100, then y is going to be 100 more than that. So y is going to be 200. And that is the same as 1 to 2. So the correct ratio is that one. Question 3. The first 4 terms of a sequence are -10, -8, -6, -4. Circle the expression for the nth term of this sequence. Okay, now I can see straight away that this is a linear sequence, because if we have a look at the gap between these numbers, you can see that it's increasing by 2 each time. So this sequence has something to do with the sequence 2n. Now 2n is the numbers 2, 4, 6, 8. We don't have the numbers 2, 4, 6, 8. We've got the numbers -10, -8, -6, -4. And the difference between these two numbers is 12. So our nth term is going to be 2n subtract 12. It's going to be that one there. Question 4. Circle the equation of the line that is parallel to the x-axis. Okay, so if you've got a pair of axes like this, x and y, then the line that's parallel to the x-axis is going to be a line that looks like that, isn't it? Okay, or one that's underneath it. Now let's consider the coordinates of the points that lie on a line that looks like this. Let's say that number up there was 2 that it passed through the y-axis at. Then that point there is going to be the point 0, 2. And then you're going to get 1, 2. You're going to get 2, 2, 3, 2, and so on. And what all these 4, 2, and what all these points have in common is that their y coordinate is equal to 2, which is why this line has the equation y is equal to 2, and that is true for any line that is parallel to the x-axis. It's going to have an equation that y is equal to whatever that x coordinate is. So if we're having a look at these lines here, then I can clearly see that those two can't be it because they're slant lines, aren't they? X equals 3 is a vertical line, so it's not that one, so it has to be that one there, y equals -5. And it will be this line down here where that point there is -5. So it's a parallel line going through y equals -5 down there. Okay, question 5. Multiply out and simplify x minus 8 all squared. Okay, now x minus 8 all squared is not just distributing that there and there and saying it's x squared minus 8 squared. That isn't right. You're going to get it wrong if you try it that way. Actually, what you need to do is rewrite this down as x minus 8 multiplied by x minus 8. It's actually a double bracket question. Now, you might have a way of remembering how to multiply this out. There are different ways. Some people call it claw, some people call it foil, some people call it 2 eyes, a nose, and a mouth. But whichever way you remember it, you have to remember to multiply everything in the first bracket with everything in the second bracket. So I've got x times x, which is x squared. I've got x times minus 8, which gives me -8. I've got -8 times x, which is -8x, and I've got -8 times -8, which is +64. Once I've written my 4 terms out like that, you'll notice I've got 2 terms in x in the middle, which I can combine together to make x squared minus 16x plus 64. And that is my final answer. Question 6. Show that 268 can be written as the sum of a power of 3 and a square number. Okay, in other words, we need 3 to the power of something plus something squared, and that is going to be equal to 268. Okay, now, probably the easiest way of going about this is just by just being systematic. Let's start with let's start with 3 to the power 1 and then see what the remainder is and see if that's a square number, and then we'll build up our powers until we find the right answer. So 3 to the power 1 is just 3, isn't it? So what would I have to add on to 3 to get 268? I would have to add on 265, wouldn't I? 265 plus 3 is 268. Is 265 a square number? Not that I know of. I don't think so. So let's try the next one. So the next power of 3 is 3 squared, which is 9. And 268 subtract 9 is 259. Again, is 259 a square number? It's not one I recognize. So let's carry on with this process. So 3 cubed is 27. 268 less 27 is 241. Now I kind of know all the square numbers, and these aren't square numbers that I recognize, so I'm just going to carry on. 3 to the 4 is 81, and 81 subtract from 268 is 100 and what's that? 187. Again, having memorized the first few squares, I can recognize that that isn't one, so I'm going to carry on to the next one. 3 to the power 5. Now, you might not know that off the top of your head. You can just type it into the calculator. 3 to the power of 5, 243. 243. 268 minus 243 leaves us 25, doesn't it? And 25 is a square number. So show that 268 can be written as the sum of a power of 3 and a square number. So then I can just write that 268 is equal to 3 to the power 5 plus 5 squared. Done. Question 7. Here is some information about the times taken by 40 people to fill in a form. So I've got 4 different groups there, and I can see that 3, then 9, then 11, then 17 people took that amount of time. Now if I want to know which class interval the median lies, now I know I've got 40 people, so to find the group for the median I need to take my number of people, add 1, and then divide by 2, and that will tell me where the group is, or which person is in the group. So 40 plus 1 divided by 2 is the 20.5th person, so halfway between the 20th and the 21st person. Probably the easiest way of doing this is looking at cumulative frequency. So the first 3 people in that category, then up to 10 would be 3 plus 9 would be 12 people, and then after that it would be the 13th up to the 23rd person there, just adding those 3 numbers together, the last cumulative frequency being 40. Now looking at the cumulative frequency, it's pretty clear to see that the 20th and the 21st person must be in that group there. It's the 10 to 15 category. Just running through that again. Person number 1, 2 and 3 are in category in the first category, then 4 through 12 are in the second category, and then 13 through 23 are in the third category. So the 20th and the 21st person are both in the 10 to 15 group. That one. Question 8. ABCD is a parallelogram. AB is equal to BP. And we've got the diagram there. Some of the information is already marked on there. I can see on the diagram already that they've marked that AB is equal to BP. But actually they haven't marked on this information, have they, that ABCD is a parallelogram. Now if ABCD is a parallelogram, it means that this line here, AB, is parallel to this one, CD. And the baseline here, BC, is parallel to this line up there. Okay, now that information isn't on there, it's quite important. So I'm going to add it on. Now we need to work out the size of angle X. You'll see that X actually appears in 2 instances here. I've got it here and here. Together they make 4X down there, don't they? Okay, I'm not quite sure I'm going to get over there yet. Now I have to start with the angle that they've given me over here. And that one lies in an isosceles triangle here, and that's one of the base angles of the isosceles triangle, isn't it? So if that 51 is one of the base angles, then that angle up there is the other one, so that one must also be 51. And if those two are 51, then this one up here must be 180 minus those 2 lots of 51, isn't it? So 2 times 51. So 2 times 51 is 102, and 180 subtract 102 is going to give me an angle of 78 degrees. Okay, so that's 78 degrees in there. Opposite angles in a parallelogram are equal. So I know that that one up there is going to be 78 also. Okay, can I work out X yet? Don't think so. Got some more work to do somewhere, I think. I think the best way now is to use the properties of parallel lines. Now, if you've got a pair of parallel lines and a line crossing them, then that forms a bunch of angles. And you should know that you've got corresponding alternate and supplementary angles. And here we've got a pair of supplementary angles, haven't we? So my 2 angles down here, my X and my 3X, are going to have to be supplementary to my 78. In other words, that those 2 angles sum to 180 degrees. Okay, so I know that X plus 3X, which is 4X, plus my 78 degrees, must be equal to 180 degrees. Okay, because those 2 angles are supplementary. So taking the 78 to the other side, that means that 4x must be 180. Subtract 78, which is 102. And that means that x must be 102 over 4, which is, what's that, 25.5? 25.5 degrees. Okay, so that's my answer, 25.5 degrees. Question 9a, rearrange v equals u plus at to make t the subject of the formula. Now, you have to think a little bit about BIDMAS when you're doing these. Now, BIDMAS says brackets, indices, division, multiplication, addition, subtraction first. So if you were working this out, you would first multiply these two together, and then you would add on the u. And then when you're changing or rearranging these, you have to kind of go in the reverse order of what you would do in BIDMAS. So however you would calculate this if it was numbers, you have to go through the list in the opposite direction. So if I was going to evaluate u plus at, if I knew what u, a, and t were, I would times a and t together and then add on u. So rearranging it, I've got to move those in the opposite order. So I'm going to move the u first, and then I'm going to move the a. We use a kind of mnemonic change sides, change signs. In other words, if I move something over the equal sign, if it's a plus on one side, it becomes a minus. If it's a times on one side, it becomes a divide. So I'm going to move this u over the equal sign. So it's going to go from plus u on the right to a minus u on the left. So I'm going to get v minus u equals at. And then the next thing I'm going to do is I'm going to cross multiply that a. So it's times on the right hand side of the equation. So once it moves over the equal sign, it becomes divide. So it's going to be v minus u over a is equal to t. So t equals v minus u over a. Okay, and that's it. Now, those of you sticking around for A-level next year might want to know that that is one of the equations of motion. Comes up a lot in your mechanics work that you're going to be doing. So one to look out for in the future. Right, 9b, complete this table with consistent metric units. Okay, so I've got distance in m, which stands for meters. Time is s, which is seconds. Speed, can you remember how these relate to each other? Some people remember this using the DST triangle, distance, speed, time. So speed is equal to distance divided by time. So if my distance is in m and I divide it by s, then I'm going to get as my units m divided by s, or meters per second. Okay? And acceleration is meters per second, or meters per second squared. You can also write this down as ms to the minus 1 and ms to the minus 2 as well, if you like. These are alternative notation. It's like index form, isn't it? 1 over s is the same thing as s to the minus 1. So, and 1 over s squared is the same thing as s to the minus 2. So there is an alternative notation that you can use there as well. Both are acceptable, and both will get you the marks in this case. Question 10. Construct a locus of points that are the same distance from A and B. So for this question, you're going to need your compasses and a ruler. So first off, put your pencil in your compasses. Make sure the tip of the pencil and the tip of the compass are in the same place, and tighten them up nicely. It's a good idea to keep a small pencil so you can twirl it around without bumping into your hands. You don't want a big pencil. Okay, so then put the compass tip into one of your 2 points. Make sure the distance between the aperture, or the distance between the pencil and the tip, is more than half the way between your 2 points. Like 2/3 to 3/4 is a good idea. Then stick the compass point in one point and draw an arc between your 2 points, and then switch over to the other point and draw a second arc. And what you'll find is those 2 arcs cross at 2 points, So once you've got your two arcs and your two crossing points, you pick up your ruler, you align it up with your two crosses, and you draw your straight line between them. And that will be your perpendicular bisector. Question 11. 42 men and 38 women visit a restaurant. 44 of these people have a voucher. 3 times as many men as women do not have a voucher. Complete the frequency table. Okay, so we're starting with this first circle, which I assume means everybody. How many people are there altogether? We've got 42 men and 38 women, giving us a total of 80 people. So we can have 80 people to start off with in this circle here. Okay, so how many are yes and how many are no then? So 44 people have a voucher. So that means that 44 people, yes, they do have a voucher. And then 80 subtract 44 is going to give me 36 people who no, don't have a voucher. And then, okay, 3 times as many men as women do not have a voucher. So that means for every 3 men we have here, we've got 1 woman. In other words, I want to take the number 36 and I want to divide it into the ratio of 3 to 1. Now, 3 plus 1 is 4. So if I take 36 and I divide it by 4, I'm going to get 9. That tells me how many shares each person is going to get. So multiplying 9 by 3, I'm going to get 27, and multiplying 9 by 1, I'm going to get 9. So that means dividing 36 in the ratio of 3 to 1 gives me then 27 men don't have a voucher, and 9 women don't have a voucher. Okay. Right, how are we going to work out then men and women who do have a voucher? Okay, I think what we're going to have to use is this piece of information at the top, that 42 men and 38 women visit the restaurant. If I know that 42 men visit the restaurant and 27 don't have a voucher, then 42 subtract 27 must have a voucher, and 42 subtract 27 is 15. And I know that 38 women altogether visited the restaurant, and only 9 of them had didn't have a voucher. That means the frugal women must have had, well, there must have been 29 of them then, mustn't it, that did have a voucher. Obviously better at planning ahead than the chaps. 29 and 9 makes 38, that's right, isn't it? So that is my final chart. 11b, a voucher takes 15% off the bill. After using the voucher, the bill for a meal is £27.20. How much was the bill before the voucher? Okay, so I teach my students how to do percentage questions using this triangle, FOM. I tell them to put their thumb on it and work out which is which. So F stands for final, O stands for original, M stands for multiplier. So I asked them to identify each of these 3 things. So a voucher takes 15% off the bill. So the multiplier then, if you've got 100% and you're doing a 15% deduction, that is going to leave you with 85%, giving you a multiplier of 0.85. Okay, after using the voucher, so that bit of information is there. So after using the voucher, the bill for the meal is £27.20. Now you need to use your past, present, future tense to work out which is which often with these sorts of questions. So after using the voucher, the meal is £27.20. So that we've been given is the final amount. Okay, so the final amount is £27.20. Okay, So the original amount before the deduction is the one we don't know and the one we want to find. Yeah, look, there it is, before. So that's got to be the original price. So what this method does is says is you cover up the one you want to find, which is that one, and it's a bit like distance, speed, time triangle that you can use the triangle to work out what to do with the other numbers. So I'm going to be using the formula original equals final over multiplier, and that is equal to £27.20 divided by a multiplier of 0.85. We actually call this sort of problem a reverse percentage question because we are working backwards, aren't we? We know the final price and we want the original. But if you follow the method that I'm using, you just really need to be clear in your own head which is which. That gives me the answer on my calculator of 32. So the original price then was going to be £32. Okay. You can actually use this FOM triangle for any percentage question, and if you check out some of my other videos, you'll see how I apply it to all sorts of percentage questions. So make sure you go through the rest of the videos. Question 12. The distance by road from Newport to London is 140 miles. Tom travels by coach from Newport to London. The coach leaves Newport at 1:30 p.m. He assumes that the coach will travel at an average speed of 50 miles per hour. Use his assumption to work out the arrival time in London. Okay, we were just talking about the DST triangle, so let's just draw that out now. Distance, speed, time. Right, so what have I got here? I've got the distance. That is 140. Time is what I need to work out, isn't it? I need to work out the time he arrives in London, and I know the average speed is 50. Okay, that's in miles and that's in miles per hour. Okay, so the one I want to find is t. So kind of putting your thumb on top of the t, it tells you what to do with the other two. Time is equal to distance divided by speed. So time taken is equal to distance travelled divided by average speed, which is 140 miles divided by 50 miles per hour, which gives me 140 divided by 50. It's giving me 2.8. Now that's a decimal number. So it's 2 hours and 0.8 of an hour. So how many minutes is 0.8 of an hour? Well, there are 60 minutes in an hour. So 0.8 of an hour, 0.8 times 60 is going to give me 48 minutes. So that is equals to 2 hours and 48 minutes. Okay, so if we remember, we left Newport at 1:30 p.m. So if we're traveling for 2 hours and 48 minutes, so I'm gonna have to add that time on then, aren't I then? So 1:30, 2:30, 3:30. 30 minutes takes me up to 4 o'clock, and then I've got another 18 minutes after that to add on. So that's 4:18, isn't it? So 4.18 p.m. In part B, we're told that in fact the coach has a lower average speed than this, so it's not going as fast as 50 miles an hour. So this speed here then is going to be less than it used to be. Okay, so if you're going to divide through by a smaller number, then this number is going to get bigger, isn't it? So if you divide by something by a smaller number, you're going to get a bigger result. So that means the time is going to increase. So, and if the time is going to increase, then I'm going to be arriving later than the time that I had before. So in fact, the coach is going to arrive later. It will arrive later than planned. Question 13. Here is some information about the length of time cars stay in a car park. So the shortest time is 30 minutes, the longest time is 12 hours, the lower quartile is 2 hours, the interquartile range is 3 hours, the median time is 4 hours, and we need to draw a box plot to show this information. Now, a box plot consists of a box with a line in it and two whiskers that spread out like that. This value down here is going to be the lowest value, so that is going to be my 30 minutes. The one at this end is going to be the longest time, so that's going to be my 12 hours. The lower quartile is this one here, that's Q1, so that's going to be 2. The interquartile range is 3. That means that the distance between Q1 and Q3 is going to be 3, and 3 more than 2 is 5, so that one's got to be 5 up there. And we're told that the median is 4. That's my value of Q2 goes in the middle. Okay, so now I know where all my values are. It's always a good idea to do a little sketch like this. Just sketch it out before you commit pencil to paper, and then you'll get a neat go first time. Okay, so we're going to mark all those values on. So time to get the ruler out. Right, so I'm going to draw a line at 30 minutes, which is half an hour. So that's going to be halfway between 0 and 1. Now you should be drawing this in pencil. I'm going to use blue ink because my pencil won't show up very well. But all diagrams should be done in pencil. Then I'm going to draw a line at 2. That's going to be my lower quartile. I've got to draw a line at 4. That's going to be my median. I'm going to draw a line at 5. That's my upper quartile. And I'm going to draw a line at 12. Showing this off the line, oh no, that's no good. And one at 12 then. That's going to be my highest value. Okay, and spinning the ruler around. I'm going to make my box here. And then I'm going to draw my whiskers, reaching up and down to my highest and lowest values. So a line there, and a line there. Okay, perfect. Question 14, we've got a Venn diagram. Now this little squiggly E stands for the universal set. So the universal set represents 31 students in the class. So that's the total number of things being represented inside this Venn diagram. C is the students who have a cat, and D is the students who have a dog. One of the students from the class is picked at random. Work out the probability that the student has a dog. Okay, we've got a bit of algebra to do first because we've got some algebraic values here and here, but it should be no problem for us to work out. Remember, we've got 31 students altogether, so if I add up all the different values in each of the ranges of my, or the different areas of my Venn diagram, it should add up to 31. So if I take my 6 and the 5 and the 2x and the x plus 2 and I add it together, that must be everything. That must be my 31. Okay? So I've got a linear equation in x that I can go on and solve. So collecting like terms together, I've got numbers here at 6, 5 and 2. That adds up to 13. So I've got 13 and I've got 2x and x, which adds up to 3x. So 13 plus 3x equals 31. Taking my 13 over to the other side, I'm going to get 3x equals 31, subtract 13. 31 subtract 13, 31, 21, 18, isn't it? So 3x is 18. And then finally, to find x, I can divide through by 3. X equals 18 divided by 3, x is 6. Okay, now remember, that wasn't the question though. The question wasn't find x. The question was work out the probability that the student has a dog. Okay, so the probability of success is So probability of a dog is going to be successful outcomes. How many students there are with a dog. Okay, so we've got 5 people have a cat and a dog, and 2x people that have a dog. Now we know that x now is equal to 6. So there are actually 12 people who have a dog then. 2 times 6 is 12. So that's 12 people have a dog only, but the students who have a dog is going to be both those added together then, isn't it? So it's the 5 and the 12. So there are actually 17 students who own a dog. So probability of success is successful outcomes divided by total outcomes. Now there are 31 people altogether in the universal set, so that means 17 out of 31 is our probability. Now normally in probability questions you don't get any credit for simplifying or breaking that down in any way. So you may as well just write down the answer as 17 over 31 and don't risk making an error by trying to simplify it in some way. I'm not sure you can anyway, because 17 is prime and so is 31. Don't think it's going to simplify anyway. So let's just leave it like that. 17 over 31, that's my answer. So question 14b says, one of the students who has a cat is picked at random. Work out the probability that this student has a dog. Okay, so this is what we call conditional probability. We're being asked, what's the probability that someone has a dog given that they have a cat? Okay, so what's the probability that they have a dog given that they have a cat? Okay, now if they've got a cat, it means, let's just tidy up this Venn diagram for a second. Let's just get rid of all that blue. Okay, if they've got a cat, then they're somewhere in here then, isn't it? They're in this purpley bit. So there are 11 people altogether in that purpley bit. So given that they've got a cat, they must be one of those 11 people. And of those 11 people, 5 of them own a dog. So the probability of getting that they have a dog given that they have a cat is going to be 5 out of 11. 5 out of 11. Question 15. Circle the highest common factor HCF of 6xy squared and 4x cubed y. Okay, so the highest common factor is going to be all the factors of those various components. So what is the highest factor of 6 and 4? That is going to be 2. And the highest factor of x and x cubed, well, x goes into x and x goes into x cubed, so I'm going to take out an x out of those two. And the highest factor of y squared and y is just y, isn't it? Y goes into y squared, y goes into y. So the highest common factor of both terms is going to be 2xy. It's going to be that one there. In question 16, we're given the function f of x, which is equal to x squared minus the cube of x, and we need to circle the value of f of minus 3. Right, f of minus 3 is going to be where we take x and we replace it with minus 3. So minus 3 squared minus, negative 3 squared minus negative 3 cubed. Negative 3 times negative 3 is positive 9. Subtract negative 3 cubed, negative 3 times negative 3 times negative 3. Negative times negative is positive times another negative is negative again, isn't it? So it's negative 27. So 9 minus negative 27. And taking away a negative is the same as adding. So 9 plus 27 is 36. It's that one there, isn't it? Question 17. At a football game, the number of men to the number of the women to the number of children is in the ratio of 13 to 5 to 7. There are 4,152 more men than women. Work out the number of children at the game. Now there's 101 different ways of doing this, so you might have approached it in an entirely different way to me. I'm going to start by writing down the ratio that I've been given. So men to women to children are in the ratio of 13 to 5 to 7. And I'm told there are 4,152 more men than women. So if I let the number of women be x, then the number of men is going to be x plus 4,152. Now, comparing these two statements, I can see that if the ratio of men to women is 13 parts men to 5 parts women, then this 5 parts is equal to that x there. So if I break this 13 parts into 5 parts and 8 parts, then again, look, that x there is the 5 parts, and that means that 4,152 must be the 8 parts. So that means that if I take 4,152 and divide it by 8, 4,152 divided by 8, I get the answer 519. So those 5 parts of women would be 5 lots of 519. So 5 times 519 means there was 2,592 women, and there were 13 lots of 519 men. That's 6,747. So there must have been 7 lots of 519 children. So it must have been 3,633 children. So that is going to be my answer then, isn't it? That one there. So there are 3,633 children. Now, like I say, there are 101 different ways of doing this, and there are probably some more formal approaches to answering this sort of question, but at the end of the day, you've got to get the right answer, and the right answer is 3,633. Question 18, expand and simplify 3x squared plus 2 times 2x plus 5 minus 6x lots of x squared minus 3. So lots of lovely algebra. Okay, so on the left-hand side here, or the first part of it, I've got double brackets, so I'm going to do FOIL on those, or claw method, or smiley face method, whichever way you talk about it. So the first term is going to be 3x squared times 2x, and that gives me 6x cubed. Then I'm going to be multiplying 3x squared by 5, and that is going to give me 15x squared. Next I'm going to be multiplying 2 by 2x, which is going to give me 4x. And then finally I'm going to multiply 2 by 5, which is going to give me 10. So there are my 4 terms from multiplying out that first set of double brackets. Now then I've got a single bracket here, so I can multiply everything in here by that term sitting on the outside. But remember, that term on the outside is negative. So as I multiply through, I'm going to be flipping the sign of the things that are inside the brackets. So just take care with the minus signs here. So negative 6x times x squared, that is going to give me negative 6x cubed. And negative 6x times negative 3, a negative times negative is a positive, and 6x times 3 is 18x. Okay, so we've multiplied everything out now, so now it's just a matter of collecting like terms. Now, I've got a 6x cubed term at the beginning and another one further in, and one is positive and one is negative. So those two are just going to cancel each other out. They're just going to disappear and drop out of the equation. Let's see if we can collect terms in x squared now. So that one went with that one. They were the x cubed terms. Now x squared terms, I've just got the 1 here, haven't I? So that can go at the front of what I've got left. Then have I got any terms in x? Yes I do. I've got 1 there and I've got 1 there. So 4x plus 18x is 22x. And finally, have I got any constants? Yep, I've got 1 there, look. So plus 10. Okay, so I've got 15x squared plus 22x plus 10. Well, that was quite easy, wasn't it? All done, 4 marks. Okay, on to circle theorems. A, B and C are points on a circle. CD is a tangent to the circle. And we need to write down the size of angle X and give a reason for our answer. Okay, so here's angle X. It's the angle between the tangent and the chord AC. Now, because I know my circle theorems, I've easily spotted that because this is a tangent and this is a chord drawn at the point of contact, and this is an angle subtended off that chord in the alternate segment, then I know that that angle there is the same as my angle X. That's the alternate segment theorem in action. So I can just say that X is 65. So X is 65 degrees, and the reason is the alternate segment theorem. That's just enough. Just writing that down as the reason is good enough. Question 20. W is a positive number. X is 10% more than W. Y is 10% less than X. Which statement is true? Okay. So we've got to take care here, because adding 10% to something and then taking it away again doesn't necessarily going to take you back to the same place. So let's think about it. Let W be 100%. Okay, then X is 10% more than W. So X then is going to be our 100% plus 10%, which is 110%. And Y is 10% less than X. Now 10% of 110 is 11. So if I'm going to subtract 10% from X, I'm going to be subtracting 11 from X, which is going to give me 99%. So W is 100%, X is 110%, and Y is 99%. Okay, and now I feel I can answer these questions. Which statement is true? Tick one box. Is W less than X? Yes. And is W less than Y? No, that's not true. Is W less than X? Yes. Is W equal to Y? No. Is X greater than Y? Yes. Is W greater than Y? Yes. It's that one, isn't it? Let's just double check the last one. Is X greater than Y? Yes. Is W equal to Y? No. So it is just that one there then. Okay. Right. Question 21. N is a number. As a product of prime factors in index form, n is equal to 2 times 3 to the power 4 times another number y to the power of 3. Work out 3n squared as a product of prime factors in index form. Give your answer in terms of y. Okay, so we know that n is 2 times 3 to the 4 times y to the 3. So if I want to work out 3n squared, I'm going to be taking n, I'm going to multiply it by 3. So 3 lots of 2 times 3 to the power 4 times y cubed. And then I'm going to square it. Okay, now BidMath says indices come before multiplication. So I'm going to deal with this index here first. And when I've got an index of an index like this with multiple things inside the brackets all multiplied together, I kind of have to distribute this to each of the terms in that product inside the brackets. So I'm going to square each part of it separately. So I'm going to square 2, I'm going to square 3 to the 4, and I'm going to square y cubed. So that's going to give me 3 lots of 2 squared, well, it's going to be 2 squared because we're going to leave it in index form, times 3 to the 4 squared. When you have an index of an index, you multiply the indices together. So that's going to give me 3 to the 8. And then times y cubed all squared. 3 times 2 is 6. So that's going to give me y to the power of 6. Okay, so now I've got 3 lots of 2 squared times 3 to the 8 times y to the 6. Now those things are all just multiplied together, so I can just combine this term with this term. If I've got 3 to the 8 and I times it by another 3, I'm simply going to get 3 to the 9. So I'm going to rewrite this in ascending power. So 2 squared times 3 to the 9 times y to the 6. And that is going to be my final answer. Question 22. Here's a triangle. It's PQR. I've been given 2 sides and an angle, and I'm being asked to work out the length of PR. Okay. Now, whenever you've got a triangle and sides given and angles given, you're asked to work stuff out. It's nearly always going to be trigonometry, isn't it? Now, this is not just your standard trig ratios because it's a non-right angle triangle. Non-right angle triangles, you've got 2 rules that you can use. You've got the sine rule and you've got the cosine rule. So usually with these sorts of questions, the first decision to make is which one of those 2 you're going to use. Now, the way I remember it is I think that the sine rules is about opposites. So you want 2 pairs of opposite sides and angles. So if I had a triangle and I knew this angle and I knew this side and I knew this angle and I wanted this side, then I'd be using the sine rule. So it's all about opposite pairs. So that's going to be the sine rule. Now that isn't the case here. I've got this angle here, 120. I want to find the opposite side, so that's good. But I haven't got another pair of side and opposite angle. I've just got 2 other sides. So the sine rule is not the thing I'm going to be using here. Now the cosine rule is useful either when you have all 3 sides, you know about those, and you want an angle, then you can use the cosine rule. And the other time you can use the cosine rule is if you've got 2 sides and an included angle and you want the other side. And in that case, the cosine rule is the one you want. And that is what we've got going on here. I've got 2 sides and an included angle, and I want to find the other side. So we're going to be using the cosine rule. Now, hopefully you can remember what the cosine rule is. You might remember it in terms of A, B, and C, and you should be able to then reformulate it for any given triangle. Okay, so here it's about the side. I label the sides opposite the angle. So this angle Q is going to be opposite side little q. The angle R is going to be opposite the side little r. And the angle P is going to be opposite the side little p, like that. So R is 6, P is 9, and angle Q is 120, and we want to find side Q. So let's state what the cosine rule is for this triangle then. So Q squared is equal to R squared plus P squared. It starts off a little bit like Pythagoras theorem. Then you minus 2 lots of those 2 letters again, 2RP cos, and then the angle that you've got, which is cos Q. So Q squared equals R squared plus P squared minus 2RP cos Q. Like I said, I kind of remember the form of it, and I can reformulate it for any given triangle, and that's what you need to be able to do too. Okay, so now I've got that written down in terms of triangle PQR. I can sub in the bits that I know. So R squared is 6 squared, P squared is 9 squared, minus 2 times 6 times 9 times the cosine of 120. Okay, now you can reach for a calculator already. I tend to try and do as much as I can before I pick the calculator up, because otherwise it's a long thing to type in. And actually, if you're quite good at adding up, then you can do this a lot more accurately in your head than you can on the calculator, I think. So 36 is 6 squared, 9 squared is 81, 2 times 6 times 9, 6 9s are 54, times 2 is 108. Okay, so because I know some basic maths, that is actually going to be a whole lot easier to type into my calculator already. I might just do that addition as well, because I can add up quite nicely. So that's 117 minus 108 cos 120. Okay, I'm going to type that into my calculator now. 117 minus 108 cos 120. I get the answer 171. Now Q is not 171. Wouldn't sit very nicely in that triangle at all, would it? Side 6, 9 and 171. It'd be a very odd looking triangle. Q is going to be the square root of that, isn't it? So Q is the root of 171. So let's find the root of the answer. Root answer. That's 13.076 and change. I'm going to round that off to 13.1, I think. So Q equals 13.1 centimeters. Now, does 13.1 centimeters look right in there? I think it does. I think that looks quite sensible. I'm going to go with that with my answer, 13.1. Question 23. Joe draws this graph to identify the region R represented by the inequalities y is less than equal to x plus 2 and y is greater than 3 minus x and x is less than 3. Okay, and there's his graph. Make 2 criticisms of his graph. Okay. Right, so let's just check that the 3 lines are plotted correctly. Is that the line x is equal to 3? That one there, is it? Yep, it is. All the points on there have x coordinate 3, so that is correct. Okay, is that the line y equals x plus 2? Well, it has a gradient of 1 and it passes through x is equal to, y is equal to 2, so it seems to be. Let's just check the last line, y is greater than 3 minus x. Is that the line y is 3 minus x? Yep, it is. So all the lines are drawn correctly, so that isn't the issue. Okay, so what is the issue then? Well, you'll notice that he's taken the line y equals 3 minus x and drawn it with a dotted line, whereas the other 2 are solid. And actually, it should be the other way around, shouldn't it? The line x is less than 3, or strictly less than 3, should be the dotted line. So this one should be dotted, and it isn't, it's solid. And y equals 3 minus x should be dotted, which it is. And y is less than x plus 2 should be solid, and it is. Okay, so there's that one there, isn't it? So it's the line x less than 3 should be a dotted line. So that's my first criticism. X less than 3 should be a dotted line. Why is that? Because x equals 3 is not part of the region. That's why we use a dotted line. It isn't part of the thing that we're drawing. So that's the first criticism. Okay, so now we've checked all the lines are right and of the right type, style. Let's have a look at the next criticism. Now you'll notice that he's drawn R here, which would indicate then that the region that we need is this region down here. I'm not sure actually that is the right region. Let me just remove that again. Where should R be? So we're saying that x has got to be less than 3. So it's got to be to the left of that line there. Y is greater than 3 minus x. So actually I think it should be that side of the line. and y is less than or equal to x plus 2, and I think it's going to have to be that side of the line. So I've got a feeling that this is the region that we should have. Now the best way to just confirm that is to pick a point somewhere in the region. I'm going to pick that point there, which is the point 2, 2. Seems like an easy point to test. And I'm going to try those values of x and y in each of the inequalities and make sure that they're true. So for 2, 2, so when x equals 2 and y is equal to 2, then y less than or equal to x plus 2 is going to be 2 is less than or equal to 2 plus 2. Is 2 less than or equal to 4? Yes, it is. So that is true. Is y greater than 3 minus x? Is 2 greater than 3 subtract 2? So is 2 greater than 1? Yes, it is. And then finally, is 2 less than 3? Yes, it is. So the point 2, 2 satisfies each of those inequalities. So R is actually that region there. Okay, so my second criticism then is that he's put R in the wrong place. R is in the wrong place. It should be by. It should be in the region containing 2, 2. Okay, that's probably overkill. Probably just R is in the wrong place would have been enough, but I like to be thorough. Question 4. The ratio of A to B is 9 to 4, and we're told that 10B is equal to 7C. Now we need to work out what the ratio of A to C is. Okay, so what's the ratio of A to B to C? What do we know about these three ratios? Well, we know that the ratio of A to B is 9 to 4. We know that 10B is equal to 7C, so then the ratio of B to C is in the ratio of 7 to 10. Okay, so I know that A to B is 9 to 4 and B to C is 7 to 10. So what I want to try and do here is come up with a number that's a multiple of 4 and 7, so I can express all this as one ratio, and then I can compare my A with my C. So 4 times 7 is... 4 7s are 28. So if I make this one 28 here, then I would get that by taking my ratio of 7 to 10 and times it up by a scale factor of 4. So that means my C value there must be 4 times 10, be 40. So my ratio of B to C of 7 to 10 is the same as the ratio of 28 to 40. Now let's have a look at the other side. If I've got a ratio of A to B of 9 to 4 and I scale that up so that B is now 28, I would have times it by a factor of 7. So if I'm timesing B by 7, I have to times A by 7, and 7 9s are 63. So I've taken my two separate ratios and made one kind of combined ratio for all of A, B and C, and now you see I can compare A and C and say that then the ratio of A to C must be the ratio of 63 to 40. That's not in its lowest form, is it? Naughty me. So the ratio of A to C is 63 to 40. Can I cancel that down at all? You can actually use your fraction key to check these sorts of things. I'm just going to type 40 over 63 as a fraction and see if that cancels down. No, it doesn't. So that is already in its simplest form. So I'm just going to write that down as 63 to 40. Question 25. We're told that liquid is leaking out of a container and that the graph shows the depth of the liquid for 60 seconds. So you can see that the depth of the liquid is falling quite quickly at first, but it kind of tapers off. So use the graph to work out an estimate of the rate of decrease of the depth at 10 seconds. You must show your working. Okay, so at 10 seconds is here. Now, if we want the rate of change, the rate of decrease, what we're talking about here is the gradient of the line at that point. So at that point is this point here, isn't it? So we want to know the gradient of the line at that point. Now, that line is a curve at the moment, and finding the gradient of a curve is tricky, but finding the gradient of a straight line is easy. So what we're going to do is we're going to draw a tangent to the curve at that point and say, well, the gradient of the curve at that point is going to be the same, or roughly the same as the gradient of that tangent drawn at the point of contact. I think I've drawn that a little bit. I'll just try that again. I'm not super happy with that. Let's just try that again. What you're trying to do is get the sort of same amount of space either side. I think that looks better. Okay, so I'm a bit happy with that. So now I've got my line. Now what I need to do is to pick 2 points on the line and work it out. I think I might just use the intercepts. I think that's probably the easiest thing to do. Let's just extend that line down so it crosses my axes. Okay, and then I can use the intercepts as my 2 values. So that if I take that point there and that point there, then this is the point, what's that, 33, 0. And this point up here is the point 0, 21. Meaning that this triangle has got a height of 21 and a baseline of 33. So then the rate of change is change in y 21, well actually it's minus 21 because it's going down, divided by the change in x 33. So minus 21 over 33. So tapping that into my calculator, I'm getting a answer of 0.64 to 2 decimal places, minus 0.64 centimeters per second. Now, just reading the question back, I worked out what the rate of change was, and the rate of change is negative 0.64 centimeters per second. But the question does ask for the rate of decrease. So I suppose, actually, that should be positive in that case, because it is decreasing by 0.64. It's not decreasing by negative 0.64. So I'm just going to leave it as a positive answer, I think. I don't think they would penalise you either way here, but it's kind of a poorly worded question, really. So 0.64 is my answer. Question 26. I've been given the identity a squared minus b squared is identical to a plus b, a minus b. You might recognise that. That's the difference of 2 squares identity. You should definitely know that one. And then I'm told that a and b are positive whole numbers where a is greater than b. And I'm also told that a squared minus b squared is a prime number. And the question is, why are a and b consecutive numbers? Right. This is quite a tricky question, really. Well, it's going to take a little bit of thought how to answer it. Let's start off by thinking about prime numbers and not prime numbers. Now, if I've got a prime number like 5, I can express 5 as two numbers as a product only by multiplying 5 and 1 together, can't I? Because 5 times 1 is 5, and there are no other factor pairs for 5, which is why 5 is a prime. But a number like 6, I can write as 6 times 1, but I can also write it as 3 times 2. So what makes a prime is that if I've got two numbers that multiply together to give you that number, then one of them has to be 1. Otherwise, it's not a prime. So let's have a look at what we've got here. We've got a squared. So if a squared minus b squared is identical to a plus b, a minus b, so, and we're saying that this thing here, this a squared minus b squared, is a prime number. So if this is prime, then it must mean that a plus b and a minus b, one of those things must be the number 1. Now let's have a think about a plus b. Now we're told that a and b are whole numbers and a is bigger than b. So the smallest a can be is 2 and the smallest b can be is 1. So the smallest a plus b can be is 3, isn't it? It's going to be a number larger than 3. So it's certainly bigger than 1, isn't it? So what about the other one? So that first part there can't be the 1. That means that the a minus b has to be the 1 if it's going to be prime. So a minus b needs to be equal to 1 if a squared minus b squared is a prime. So it must be that a minus b is equal to 1 if a squared minus b squared is a prime, because if it's not 1, then we've got a different factor. We've got another factor pair, so the number can't be prime. So if a minus b is 1, that means that a and b must be consecutive. So, and if a minus b equals 1, then a and b must be consecutive. If the difference between the two numbers is 1, they must be next to each other, mustn't they, on the number line? Okay, and I think that's sufficient to get those 2 marks then. Question 27. VABCD is a square-based pyramid. The horizontal base ABCD has side length 10 and center M, and we're given that angle VMA is 90 and VAM 68. Now, with these sorts of questions, a good idea just to double check that everything written in the question above is already on the diagram. In this case, it is. We were told the 2 angles, which are marked here, at 68, and the right angle, and we were told the 2 sides, and we told the shapes. There's nothing else in the written part there that we need to add to the diagram, but it's definitely always worth checking, because it isn't always the case. We've been handily given the volume of a pyramid formula. It's a third of the area of the base times the perpendicular height. Now, what do we need to do? We want to... Well, what's the question? Is there a question? No, over the page. Work out the volume of the pyramid. Okay. Right, so I know that the volume of the pyramid is a third of the area of the base times its perpendicular height. Now, the area of the base is no problem because the area of the base is, well, the base is a square, and I know both sides, so it's going to have an area of 100. But do I know the perpendicular height? So I need to know the length VM, don't I? I need to know this length here. Okay, I need to know that length, and at the moment I don't know it, but luckily I've been given some information where I can find it. Let's have a look at this triangle here, the triangle AVM. Now you'll see that this is a right angle triangle. I know one of the angles. So if I knew the side length, AM, if I could find AM, then I would have a side and an angle, and then I could work out the height that way, couldn't I, using trigonometry? But I don't yet know AM, but I can find AM using the triangle ACB, this triangle here, which is also a right angled triangle. And I can use Pythagoras theorem to find AC and then halve it to find AM. Okay, so that's my plan. So I'm going to use Pythagoras theorem first in the triangle ABC to find AC, halve it to find AM, and then use trigonometry in AMV to find the height. Once I know the height, I can shove everything into the volume formula and find the volume. Okay, now I've got a whole page to do my work over here, but it's a bit far away from the diagram. I tend to like to use the space around the diagram to work. If you prefer that too, go ahead. Your examiners will still mark everything as long as you don't go over the boxes around the edge of the page. So if it's easier for you to work near the diagram, then like it is for me, then you go for it. Right, so I'm going to kick off with the right angled triangle ABC. So in triangle ABC, I sometimes just like to take those triangles out and draw them next to my method. So I've got my triangle here. This is A, B, and C, and I know that it's 10 and 10. And what I want to do is to find AC then, don't I? So AC all squared is equal to AB squared plus BC squared using Pythagoras theorem. That's equal to 10 squared plus 10 squared, which is 100 plus 100 is 200, isn't it? So AC is going to be the root of 200. So AC is root 200. Now I could work out what the root of 200 is, but I'd be rounding off. So let's just leave it like that for now. So what's AM? So AM then is going to be half of AC. So AM is equal to 1/2 of the root of 200, or root 200 over 2 if you prefer. So now I've got AM. So now let's switch to the other triangle. So in triangle AMV, so let's just draw that triangle out so it's not so crowded. So I've got a right angle triangle again. I know this angle down here is 68. I know that's A, that's M, and that's V. Now I want to know H, the height of this this pyramid, and I know that AM is root 200 over 2, or half of the root of 200. So I should be able to use trigonometry to work out then the value of H. So in this triangle, it's a right angled triangle. Let's label up the sides. This is the longest one, that's the hypotenuse. This is the opposite, and this is the adjacent. So I've got a little handy mnemonic for remembering which trig ratio to use. I tend to write that down as SOHCAHTOA. You might have another one to help you remember. So I want the opposite. I've been given the adjacent. Don't know the hypotenuse. Don't want to find the hypotenuse. So the one that's to do with the opposite and the adjacent is the tangent one there, look, TOA. So I'm going to take that and write out the tan of an angle is equal to the opposite over the adjacent. So my tan of 68 degrees is equal to my opposite. That's the side VM, isn't it, which I called H, divided by the adjacent, which was a half of root 20, or a half of root 200, or root 200 over 2. Okay, dividing through by a fraction is the same as flipping that fraction over and times in. So actually, that is the same as tan 68 is the same as 2H over root 200, just taking that 2 down there and popping it up to the top. Divided by dividing is times in, isn't it? So I've got tan 68 is 2H over root 200. So reorganizing that for H, I should know that then that H, so let's just switch back to blue. H is equal to, rearranging that, cross multiplying the root 200 up there and the 2 down here. It's going to give me root 200 tan 68 all divided by 2. And that is then my value of h. Now again, I could calculate that now. Let's just pull up a calculator and work out what that is. So root 200, square root of 200 times the tan of 68 all divided by 2. My calculator's given me that as 17.5 to 3 significant figures. So let's write that down. That's 17.5. It's going to be centimeters here. Always a good idea to just look back at your diagram and think, does that look sensible? Does a height of 17.5 centimeters there look right? I think it does. It looks okay compared to the rest of the diagram. It's a bit longer than the sides of the base, but that looks quite right in my diagram there. So I found the height. I can now go on to work out the volume of my pyramid then. So the volume of a pyramid is 1/3 times the area of the base times the height, which is 1/3 times the area of the base is just 10 squared because it's a square, times the perpendicular height, which is 17.5. Right, I need to type that into my calculator. Now I've still got the full calculator value for 17.5. The unrounded off version one sitting as my last answer, so I'm just going to carry on tapping onto that one rather than just typing in 17.5 again. So answer times 10 squared divided by 3 gives me an answer of 583.4. So 583.4, and the units are going to be, it's volume, isn't it? So centimeters cubed. Okay, so 583.4 centimeters cubed. Question 28. Y is given as p times q to the power of x minus 1, where p and q are numbers. We're told that when y is 10, then x is 1. And then when y is 0.3125, x is 6. So work out the value of y when x is equal to 3. Okay. So what we're going to do here is we're going to form two equations by substituting in our y and x value there in one of them. And then we're going to sub that in, and that will give us two equations where there are just two unknowns left, p and q. And then we can look to see if we can solve those simultaneously. So first off, when y is 10 and x is 1, then that means that y equals p times q to the power of x minus 1 is going to be 10 is equal to p times q to the power of 1 minus 1. Okay? So what's 1 minus 1 is 0, and anything raised to the power of 0 is 1. In other words, oh, we're not going to have to solve these simultaneously, really, are we? No, that's just dropped away. Q to the power 0 is 1, and p times 1 is just p. So that means that 10 is equal to p. Okay, now we've got our second pair of values that go together. We know that y equals 0.3125 when x is 6. So subbing those in as well. So 0.3125 is equal to p times q to the power of 6 minus 1. So I subbed that in and I subbed that in, didn't I? Okay, so now I know, but I don't know p now, so I can sub that in as well. So I'm going to say that 0.3125 is equal to 10 lots of q to the power of 6 minus 1. That is q to the power of 5, isn't it? So 10 lots of q to the 5 is 0.3125. So that means that q to the power of 5 is going to be 0.3125 divided by 10. And 0.3125 divided by 10 is 0.03125. So to find the answer then, I just need to find the fifth root of that then, don't I? So if I can take the fifth root of 0.03125, 1, 2, 5. Find out what that is. I should find Q. So the fifth root, so I'm going to use that function, fifth root of 0.03125. That comes out to be a half. So Q is equal to a half. What was the question? Work out the value of y when x is 3. Okay, we're not done yet then. So now I know that Q is a half and P is 10. I now know the full equation that links y and x together. So, run out of space. Let's write underneath. So y equals P times Q times x to the power of -1. So y is equal to 10 times a half to the power of x minus 1. That's the equation, isn't it? And then when, what was it, when x is 3? When x is 3 then y is going to be 10 times a half to the power of 3 minus 1. In other words, y is equal to 10 times a half squared. Now, a half squared is a quarter, so that is y is equal to 10 over 4, isn't it? Which is 5 over 2, which is 2.5. So y is equal to 2.5. Question 29. Here's a graph of y equals f of x, where f of x is a quadratic function. And then we've got the graph, and yes, it's got that telltale parabola. Well, what we need to do is write down all the integer solutions of f of x is greater than equal to 0. Now, if you remember, f of x is this axis, isn't it? So basically, if you're asking where f of x is greater than equal to 0, you're basically saying where is the function above the x-axis. Now this function is above the x-axis for this part of the curve, isn't it? And it's below outside of that. So it is going to be when the values of x lie between here and here then. Okay, so between there and there, f of x is greater than 0. Now that value is nice and easy to read off. It's just 2. This one is a little bit trickier to read off. Got 5 little jumps between -3 and -4, so it's somewhere between -0.32 and -0.34. Looks slightly closer to 4 than 2, but I'm just going to go for halfway between them. I'm going to call that -3.3. I should think that's sufficient accuracy for this question. So that point there is x is equal to minus 3.3, and this point here is x is equal to 2. So then the range then where it's greater than equal to 0 is the range between those values. So x must lie between minus 3.3 and 2. And because that is greater than or equal to, then my two endpoints are part of the range. Okay. Oh, so I've just spotted another word in here I didn't read first off, and that is integer solutions. So given that there's got to be integer solution. Integers are whole positive or negative numbers. So the whole positive or negative numbers between minus 3.3 and 2, inclusive of the endpoints, are going to be minus 3, minus 2, minus 1, 0, 1, and 2. On the graph, basically, it's these ones like that one there, 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 and that one there. Okay, so there we go. I was going into much more detail than I needed to be before because I didn't read the question carefully. So there's a tip for all of you. Read the question carefully. Okay, question 30. The paper's finishing with some function notation. I've got f of x is equal to x over 3 plus 4, and g of x is given as 6x squared plus 3. and we need to work out fg of x. Now, with these, you start on the inside and work outwards. So the first function is you take x and you put it in g, and then that then is fed into the function f. Okay, so the first thing to do is we're going to take our function for g of x and we're going to feed it into where we see the x in f of x. Hopefully that makes sense. So f g of x is, so I'm going to, where I see the x in f of x, I'm going to write g of x. So that is 6x squared plus 3, all divided by 3 plus 4. So you can see what I've written in, what I've got here is here, and I've written it there where the x is in f of x, and the rest of what I've got divided by 3 and plus 4 is there. Look, hopefully that makes sense. So fg of x is 6x squared plus 3 all over 3 plus 4. Okay, now it's not quite in the form thereafter. I want it in the form ax squared plus b, and I've got a kind of more complex looking thing going on here. Now, let's see if we can simplify this out. Well, first off, 6x squared plus 3, that factorizes, doesn't it? I can take 3 out as a common factor. So that's actually 3 lots of 2x squared plus 1 divided by 3 plus 4. And you'll see that the reason I've done that is that I can then just cancel those two away. 3 divided by 3 is 1, so I just end up with the bracket. So that becomes 2x squared plus 1 plus 4. And then add in my 1 and my 4 together. I'm going to get 2x squared plus 5 as the final answer. So that is in the right form. Look, 2x squared plus 5 is in the form ax squared plus b. So a is 2, b is 5. Okay, done. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.